Okay, now we are starting with section 3 of chapter 5. As I told you, I skipped that section because I thought section 4 is easier to understand and will make that section much more easier to understand. Now you know the substitution method for indefinite integration. Okay, indefinite integration is the integration that has got no limits, no lower limit, no upper limit. Now we are studying substitution method for definite integration. What is definite integration? It is the integration that has got limits, upper limit and lower limit. You're doing the same procedure that we did for indefinite integration. We are letting u into something, finding du, and then transforming the integration that is given to you into something of terms u, and then you have to put the bounds of the integration into the result that you get. That's the only step that will be added to this section. Okay, so let's start with an example. Okay, example 1, we have got evaluate. Okay, look, I'm not writing the substitution method of definite integration because you're doing the same steps that we did previously for section 4. Okay, but instead of stopping at a point and make it plus c, you know, in definite integration we do not have plus c. You will get a result out, okay, not a function plus c. So we have got evaluate the integration of -1 to 1 3x squared, and under the square root we have got x to the power of 3 plus 1 all dx. Okay, so what do we have? We have got here definite integration. It doesn't make a difference. You can take this one away and solve the integration as it is without the bounds, and then we will use the bounds at the end. Okay, so let's look at this function as it is. Okay, as it is an indefinite integration. So what do we have here complicated under the square root? We have got this part. So I will let this part, okay, let u that's equal to x to the power of 3 plus 1. We said after u we are directly finding the derivative of that u. Okay, I will leave these bounds. Okay, I will not think about this bound and that bound. I will think about it as a definite indefinite integration. So I'm coming to change the integration, okay, but without any bound. That's equal to what? That's equal to, instead of square root of this part, I have got square root of u. Instead of having 3x squared dx, because we have to transform it all, I have got here 3x squared dx, that's equal to du. Look, here I didn't write these bounds for this one. Why? Because these bounds are for x, it's not for u. I have transformed the integration to u, so I'm not putting that -1 in here because that -1 is belonging to the x that is given in here, not to the u that we have formed. Okay, so please, when you're transforming that integration into u terms, do not write the bounds because the bounds belong to x and not to u. Okay, that's something simple. So I will have integration of u to the power of 1 over 2 du. Okay, solving this one will give me what? You know, we are increasing this one with the power of 1 over 3 of 2, but I will not write plus c here. Why? Because here I have got definite integration. Okay, so this step you have to, at this part you have to skip it and you will not write it. Instead of that c, what will we do? We will see it here. Okay, because in indefinite integration that was the result for u. Now we are changing the u back to x. Okay, so that will equal to what? 2 over 3, because I'm taking this one also up. Instead of u, what do I have? I have got x to the power of 3 plus 1 all to the power of 3 over 2. Now what will I do? I will write here from -1 to 1. Why? Because I changed u back to x. And what are the bounds for x? It is -1 and 1. Okay, so is that obvious? First, we did the substitution method. We transformed the integration into u terms. We are not writing the bounds for u because these ones belong to x, not for u. We are solving the integration that we have got in terms of u, okay? And then we are not writing plus c here because here I have got definite integration. Keep in mind that this c is vanished here, okay, because we've got numbers bounds here. Then we are changing that u as we did previously for substitution method back to x itself because I want the result to be in x. When we are transforming the u into x, I'm putting the bounds back because the x is back, so the bounds will come back. Okay, now how do we solve this one? It's easy. That will be 2 over 3. Okay, I will open a big bracket. First, we are inputting 1 into here. That will be 1 to the power of 3 plus 1, all to the power of 3 over 2. And then there is a minus, you know, for definite integration. Then I'm inputting that minus 1 into there. Minus 1 to the power of 3 plus 1, all to the power of 3 over 2, and all closing the bracket. Look, that 2 over 3 is for all of them. Once I put 1 into the function that we have got, minus, then I put negative 1 into the function that we have got, and that will give me a result. Okay, that will be 2 over 3. That will be 2 to the power of 3 over 2. And that will be minus 0, okay, because this part is minus 1 plus 1 is equal to 0. So the result of this one is equal to 2 over 3. And that is 2 to the power of 3 under the square root. Or you can take 1, 2 out and that will be, let me write it, that will be 4 over 3 square root of 2, because 2 is coming out of here. That is definite integration and substitution method. So since you know the substitution method for indefinite integration, you are doing the same procedure here, but at the end, instead of having plus c, we are inputting those upper and lower values into the function that we have got. We have got another example. We have got integration from pi over 4 to pi over 2, cosine of theta, cosecant squared of theta, d theta. Here I will not solve this one for you, just giving the hint to let u is equal to cosine of theta, then you find du that's equal to cosecant squared of theta with a negative in front of it, d theta. Then you're changing that integration. It will be u minus, because this part becomes minus du. Okay, so it's solving this one. I already solved it. Solving this one, what will I get? I will get minus u squared over 2. Okay, but look here, I didn't put the bounds again. I am solving it very quickly, sorry for that. So what are we gonna do? We are changing this one back to its original form. That will be minus cosine of theta all squared over 2, and the bound is from pi over 4 to pi over 2. Then you're inputting this one minus inputting pi over 4, and you will get the required result. Okay, now we are coming to definite integration of symmetric functions. Okay, definite integrals of symmetric functions. What do we have? We have got even functions. If we have got, of course, if you have got a function f, okay, that's continuous on a symmetric interval, okay, that means on an interval like that, from minus 2 to 2, from minus 1 to 1, minus 3 to 3, minus 5 to 5, whatever number we have got, okay, minus 10 to 10, but this one is called what? A symmetric interval. Let's see how will the functions behave if we have got a symmetric interval like that and the function that we have got is continuous on that interval. If f is even, Okay, you know what an even function means. Then minus a to a, the integration that I have got f of x dx, I can change it to 2 multiplied to the integration like that, f of x dx. Okay, so I have got a symmetric interval. If I have got the function is even, how can I change that integration? I can say that this integration can be multiplied to 2 and I will change the interval into half. For example, if the interval is from -4 to 4, I will say the integration is equal to 2 multiplied to integration from 0 to 4. So I'm cutting the integration, the interval into half and multiplying it by 2 because it's an even function. Okay. Part B, it says if f is odd, you know what an odd function is, then integration from minus a to a, f of x dx is equal to 0. Okay, that's important to know. You may have examples, I will give it to you like that, okay, and even an odd function. If you know these properties, you will be solving it much more easier. Let's give an example. It's written in your course. We are given -2 to 2, x to the power of 4 minus 4x squared plus 6 dx. If you look at that function, it's something even. Since it is even and the interval is symmetric, so I can write that this integration is equal to 2 multiplied to the half of the integration of x to the power of 4 minus 4x squared plus 6. Okay, of course, when you're evaluating this integration from 0 to 2, it is easier, much more easier than evaluating this one, because a part of it will equal to 0. Okay, solving this one, it will be easy. That will be 2 multiplied to, what is the integration of x to the power of 4? That's equal to x to the power of 5 over 5, and the integration of x to the power of 3 is equal to x to the power, x to the power of 2 is equal to x to the power of 3 over 3 plus 6x, and all the interval is from 0 to 2. Now you're substituting 2 into here minus 0 into here. If you look at here, this part, when you're putting 0 inside, it will all equal to 0 and makes the integration easier for you to be solved. Okay. No examples are given for the odd function, but let's give an example for that also. Example for this one, find integration from -5 to 5. Let's say x to the power of 3 plus x, okay, dx. That's something very simple, okay, but just to see the use of the theorem that we have got here. If you look at that function, it's an odd function. Since it is an odd function, so you do not need to solve that integration. You're directly saying that this integration is equal to 0. Why? Because the function f of x that we have to integrate it is odd. And the interval -5 to 5, okay, is a symmetric interval. Okay, or you can directly write this is equal to 0, since if f of x is odd, then integration from -a to a f of x is equal to dx also is equal to 0. So you do not need to solve this one as that's equal to x to the power of 4 over 4 plus x squared over 2, and then inputting 5 inside it, inputting -5 inside it. You see that if you do those steps, it is taking lots of your time, and you may make mistakes also while solving it. But if you know this property of odd functions and symmetric intervals, you can directly say that this integration is equal to 0 because of that reason. But I want the reason to be written right next to it, okay? Or under above it, underneath of it. Just write the reason for me, because if you're not writing the reason, you will not get your marks. Okay. Now that was about definite integration and substitution method. We are coming to area between curves. Okay, area between curves. Previously, what did we study? We studied the area between a function and the x-axis. The thing that we had, it was something like that, okay? For example, that's from A to B, and that's the function f of x. It was required from you to find the area that is between the curve and x-axis, or we could have something like that, okay? That was the area between x-axis, that's point B, between x-axis and the curve that we have got. We said first, when we were solving such kind of questions, we were first setting the function equal to 0, finding the intersection points and dividing it into sub intervals. This would have been area 1, that one area 2, and then at the end we were finding the total area is equal to the absolute value of area 1 plus absolute value of area 2. Now we are moving to area between two curves. That means if you have got something like that, let's draw something simple, okay? And we've got something like that, okay? Say this one is f of x and that one is g of x, and it's required from you to find that area. Of course, that one is A and that one is B. How do you find this region between those two curves? We say that area is equal to, okay, integration from A to B, look from A to B because that area is between this one, then f minus g d of x. Why did I say f minus g and I didn't say g minus f? Because here if you look at the function g, the function f is above the function g. Function f is greater than function g. That's why I'm writing f before g, okay? So whichever function is greater, I'm writing the greater function minus the smaller function. So it is an easy procedure. It's again integration, and it is really easy to find the solution for that integration. Okay, now we are moving to example 4 in your course material, and we are explaining how to find the area between two curves, okay? Here, when we are given two curves, to find their area, we have to find the A and the B, okay? The A and B is the intersection of the two graphs of the function. So how do I find A and B? I have to equalize the functions to each other, you know that, okay? So here, let's come to the example that we have got. It says find the area of the region. So since it is required area, so that I know that it's required from us to find the integration, okay, of the region enclosed by the parabola. So what do I have? It's enclosed by this one and that one. Two functions are given to me, okay? Their graphs are not given to us. We have got no idea about their graphs. So let's see how to solve this integration. To solve that integration, the first thing that we need to find is the bounds, okay? Is that A and B, because if these A and B are not given, how can I find the area that's enclosed by those two functions? To find those intersection points, you know that we are finding intersection points by equalizing this one by that one. I will name this one as y1 and name this one as y2. You're free, you can choose this one is y1, that one is y2. It doesn't make a difference in the solution, okay? That's just the name I'm giving it to them. So to find the intersection points, I mean A and B, okay, set, when I say set, that means put y1 is equal to y2. What's y1? That's 2 minus x squared equal to minus x. That is a quadratic equation. I will simply solve it. I'm taking this part to the other side, okay? So that will be x squared minus x minus 2 is equal to 0. Factorize this one. It's equal to what? That will, I will have x2 and x1 equal to 0. X minus 2, x plus 1. Why? Because when I multiply them, I'll get negative 2. And when I add them, I'll get negative 1. That's in the middle. So x is equal to 2 or x is equal to minus 1. Okay? So what is a and b? That would be my a, because the smaller number would be in the lower part of the integration. That would be the a that we are searching for, and that is the b. So far, what have we found? We have found the bounds, the limits of the integration. Okay, we have found this. Let me move to the previous page. I have found this a and that b. I have to also find something else to see which function is greater than the other one, so that I will put it first. Okay, if the graph is given to you, it is easy. The function that is on the top is greater than the other one. But if the graph is not given to you, there is you have to sketch the graph of it, or there is another way we can figure out which function is greater than the other. What are the numbers that I have got? It's from -1 to 2. Okay, choose a number in that interval. Look, a is -1 and b is 2. Let's choose a number in between. I will choose 0. Choose the simplest number. I will put that 0 in y1 and y2. Okay, so y1 of 0 is equal to what? If I put it here, that will be 2 minus 0 squared, and that will equal to 2. If I put it in y2, the 0 number, that will equal to minus 0, and that's equal to 0. Which one is greater? y1 is greater than y2. So in that interval that I am finding the area of the functions, the area between the functions, y1 is greater than y2. So my integration will be what? Integration will be -1 to 2. Since y1 is greater, so I will say that will equal to y1 minus y2 dx. Let's write this one, -1 to 2. Okay, y1 is equal to what? Is equal to 2 minus x squared. Okay, 2 minus x squared minus y2 is equal to what? That's equal to minus x all dx. Do the rearrangement for this one. That will be 2 minus x squared plus x all dx. Now solve this one. That's equal to what? The integration of 2 is equal to 2x minus integration of x squared is equal to x to the power of 3 plus 3, and that one is x squared over 2. And the form is, the bound is from -1 to 2. Now input 2 into here. What will I get? I will get 2 multiplied to 2 minus 2 to the power of 3 over 3 plus 2 squared over 2. Okay, all minus, I'm putting -1 into there, so that will be 2 multiplied to -1. Sorry, I'm writing it some smaller. Minus -1 to the power of 3 over 3 plus -1 to the power of 2 over 2, and I will close the brackets that I have got. Okay, evaluate this one. Look, I put 2 in here, then minus. Okay, I put -1 into here. The result will equal to, of course, you're calculating this one, it's something easy. It's written in your course material that the area between those two curves is equal to 9 over 2, and that's the required result, the area between those two curves. So what have we done? What do we need, and what have we done for finding the area that's enclosed between two regions, between two functions, we are using that integration. When we are using that integration, we need two things to know. We need to find AB, and we have to see which function is greater than the other, so we are writing it first. To find A and B is the intersection of the two graphs, so we are equalizing those two graphs to each other to find their intersection point. We found the intersection points, so it gave me the bounds of the integration A and B. Of course, we are writing the smaller number as A and the greater number as B. Then if you had the graph of the function, you would easily figure out which one is greater than the other one, so that you write which one is minus the other one. You're subtracting which function from the other. If you didn't have the graph of the function, or you couldn't sketch the graph of it, we are taking the interval that we have got from A to B. We are choosing a test number between them. We are putting that test number in the first and the second function that we have got. The function that gives me the greater result, I will say that that function in that interval is greater than the other. Now the integration becomes what? From A to B, and I know that y1 is greater than y2, so I will say y1 minus y2. Then I'm putting y1 is equal to the function that is given to me, y2 the function that is given to me. Do the simplification, integrate it, put the numbers inside it, and you will get the required result. That's all for section 3. We studied the substitution method for definite integration. We studied the integration on symmetric intervals, whether if it is an even function or an odd function, and we studied the area between two curves. Hope you would understand the subject. Have a good time, and bye-bye.